Hey everyone, Mr. Skelton here, back at it, and today we're going to be talking about Lesson 3. Lesson 3, we're going to be discussing joint or combined variation. So we're continuing our discussion on the two types of variation that we have started out talking about, which is direct variation, which is y equals a constant times x, and then inverse, which you learned in Lesson 2, which is y equals k over x. Okay? And if you remember, in direct variation, that's where we have a situation where as your x value increases, your y value increases. With inverse variation, as one variable goes up, one value goes up, then your y decreases. Okay, and so today we're going to be combining these two and in some different situations. The biggest thing that you're going to come across today is the language, being able to interpret what an equation means and then being able to write it out in words, and then vice versa, having something in words and then being able to write the equation. So let's jump right into it. The first thing I want to talk about is when you see the word jointly, that means basically multiple direct variations. Okay, so jointly has kind of a focus on direct variation, and I'll show you what I mean by that here in a second. Combined is when you're actually combining both of these together in one situation. So let's just jump right into some examples. Hopefully it'll all come into greater focus for you. So now that we're experts on direct and inverse variation, let's start to combine them. So here's a situation here where you see the word jointly. Again, if I covered this up, what I would give you on a homework question is I'd give you this equation and say, okay, write it out in words. Could you do that? Well, A varies jointly. Jointly means direct variation, right? So we're thinking direct with B and H. So what does this 1/2 represent? Well, remember, you're always going to have a k value, so that 1/2 is your k value, and you have b times h. So remember, direct variation is when you have a k value multiplied by a variable x. In this situation, we have the k value multiplied by like an x and a t, just two variables, okay? And so another way we could write this, so this is a second example. Both are correct, by the way. This would work on a quiz or a test, and so would this. A varies directly with both b and h. So you could write it this way, or you could write the word jointly because it's direct variation. The second example here is you have a equals pi r squared. So this would be an example of your pi. It's a symbol, but that's still a number. Remember, pi is 3.14, so that's your k value. So this would be a varies directly with the square of r. Or you could write a varies directly with r squared. That would be fine too. So there's a little bit of wiggle room in how you would write this out. Okay, on the bottom one again, here's what you got to be thinking. I give you number 3 and I ask you to write it out in words. Can you do that? Well, v varies directly with what? Well, this one's a little tricky. As long as you understand that this is your k value, right? Because this is actually a number, 4/3 times pi. Pi is a symbol, but yet it's still a number, 3.1415, etc. So it's really 4/3 times that number. Those together make your k value, so it's y varies directly with the cube of r. Pi is not a variable. I'll have students write v varies directly with pi and r cubed, and you can't do that because remember, pi is not a variable. It is a value. It is a k value, so you have to be careful with that. All right? Let's turn the page. And so now we're going to get into a couple examples that are a little bit more maybe difficult or challenging. And so here's what we have. Number 4, again, I want you to think of it like this. I give you number 4's equation. You have to write it out in words. So you see division. As soon as you see division, you have to be thinking inverse, right? Remember, inverse variation, the k value or the constant is on the top over the x. So this would be y varies inversely with x and z. Okay? 64 would be your k value in this situation. Here's one that is a good example of combined, right? Combined variation where we have direct variation and inverse variation taking place, right? Take a look. So m varies directly with w and x. So you can see w and x. Like if I just wrote that out, that would look like this. M varies directly with W and X. That's what that would look like. 4 would be your K value, right? But you see division, but inversely with N divided by N. So that's how you would write this out for this equation, okay? Now, here's 3 examples that I want you to try on your own. I'm going backwards. So now I'm giving you a statement. You need to write out the equation for each of these 3. Okay, write a general equation. So hit pause, try these 3, and then hit play and see how you did. All right. Y varies directly. Y equals. Y varies directly. So I know I'm going to be multiplying. My K value is just K. I don't have actual value, so I got to use K. With N, so it varies directly with N, but inversely with M. That would be division. And that was how you would write that example. W varies, W equals, directly with the square of P. Got to put my K value in there, sorry. K times P squared, but inversely with R. So divided by R. Number 9, Z varies, Z equals, inversely, K values on top over, Z varies inversely with the cube of G. G cubed. And there we go. Okay? So keep going. So now, just like we did in the first 2 lessons, we'll have some problems where you have to come up with the K value, plug the K value back into the equation, and then solve for whatever variables they're asking you to solve for. So let's take a look. Here's the meat and potatoes of the problem right here. You have to be able to translate that, just like we did in the previous examples, into an equation. Y varies directly. Y varies directly with X and inversely with Z. So that's how you would translate that. That is half the battle, if not more of the battle, is just being able to do that consistently well. Next, Y is 25, so plug in 25 for this Y here. When X is 10, plug in a 10 there, and Z is 2. Write a specific equation. All right, so this pattern is repeating itself in all 3 lessons, right? It's number one, write the equation. So that's what I'm talking about here. Number 2, you have to find your K value. Number 3, solve for whatever variable they want you to solve for. So number 1, we translated the sentence. There it is. Number 2, we got to find K. How do we do that? Well, let's keep solving. 10 divided by 2 is 5, so essentially we have 5 times K, so we divide by 5, and K equals 5. Great. Number 3, solve for the variable. So now that we know our K value, we're going to plug that back in right here, and this becomes Y equals 5X over Z. Now write a specific equation, check, done, with the appropriate K value, 5, and then find Y when X is 14. So this becomes 5 times 14 over 7. So you just take the calculator out, 5 times 14, divide that by 7, and we get 10. So Y equals 10. So that's all 3 parts right there. All right, gotta be careful there. So here's a nice way that you can kind of transition what we're learning into the real world, right? Everybody likes those real world applications. So the one thing I got to mention right away is, excuse me, I'm dying over here. I wrote this wrong. This is supposed to be the height squared. So that should just be a W. So it really should be K times W over the height squared. This is your BMI, body mass index, right? So this tells you if you're underweight, healthy, overweight, obese, extremely obese. On the left-hand side is your height in inches and in centimeters if you want to go the European route or the Canadian route. On the top is pounds, and underneath it is kilograms. So, for example, I'll use myself as an example. I'm 6'3", so there's 6'3", and I weigh just under 200 pounds. So I'd say I'm probably around about 195, all right, somewhere in there. So basically what's happening is you basically line these up together on this chart, which is already done for you, and my body mass index is at 24. So I think, according to whatever this chart says, I'm in the healthy range or very close to it, whatever. It's all good. Just giving you an example of how this works. So here's how we could make this stuff work. On the next page, I'm just going to put I'm 6'3", 195, and I have a BMI of 24. Okay? So describe the variation. So what I'm asking you to do is go back and describe or write this out. So how would you write that in words? You would say Y varies directly with W, but inversely with H squared. Or you could say the square of H. That's how, when I ask you to describe this, you have to put it into words. Part B says find the K value. All right, so how do we do that? Well, I know my BMI, right? So I know I'm going to plug in 24 equals K. My weight is 195 pounds. My height, I'm going to convert 6'3" into inches, right? So basically 6 times 12, because there's 12 inches in a foot, is going to be 70, I believe, right? 6 times 12, or 72, excuse me, 72, plus the 3 inches on top of that, so 75. Okay, so I need to solve for K. I'm going to take my calculator out. I can times both sides by 75. So 75 times 24, and then divide that by 195, and I basically get 9.23. That's my K value. Okay? And then it says write the equation, so I would have my BMI is equal to 9.23 times my weight over my height squared. That would be your equation. And then calculate your BMI with the equation. So if you want to calculate your BMI with the equation, you can. You don't have to. I'll just give you an example. And again, if I put in my 9.23 times my weight, which is 195, over my height, which is 75 inches squared, I should get my answer that I have. Okay? So that's our lesson on joint and combined variation with an emphasis on the language. You got to be able to convert from a sentence to an equation and from an equation to a sentence. You should be good to go. All right? Look forward to seeing you in class. If you have any questions, as always, let me know.